Hello everyone and welcome to this talk. The talk will be about embedded devices and testing of their user interfaces. My name is Slobodan Vrkačević and I'm one of the software developers here at FrogLogic. I gave the same talk at Squish Days in Munich in 2019. So I will first talk a little bit about embedded devices, then we'll take a look at one popular choice for the implementation of user interfaces at the embedded devices. Then we'll see how to test such user interfaces with Squish. There will be one live little demonstration and I will talk about some challenges and the problems. So let's get started. I will first talk a little bit about embedded devices and show you a few examples that might be useful for the colleagues who are new to this field or maybe not that much familiar with the terminology. So the term embedded device, there's of course no strict definition on what that exactly means, but in general people think it's some kind of computer which is put into a mechanical machine or an electrical machine, a tool or an instrument. So the main characteristic of such a computer is that it has very well defined functionality and quite often it has also a predictable workload. Let me show you a few examples. So historically this is one of the first embedded computers or embedded systems. So it helped to navigate and land onto the moon 50 years ago. It is of course Apollo guidance computer. You are of course probably more familiar with the machines like these. So these are ATMs or cash dispensers, or maybe you are also familiar with this kind of machines. So these are ticket vending machines. So the main purpose of a computer which is embedded into such machines is to control their mechanical parts and to issue a valid ticket after you put some money inside. So these would be examples of a little bit bigger embedded devices, but these days quite some people think that embedded devices are something which is rather small, and that is of course true. Approximately 10 or 15 years ago we start seeing on the market little PCBs like these here, and they would have all components of a bigger computer on them. So for example here there is a CPU, then you have some RAM, and then there is some flash for permanent storage of the device. So for the first time people could run on these little boards full desktop systems like Linux or QNX, Windows C and so on. And of course in electrical industry miniaturization continues, and these days we have something which is called system on chip. So these are almost whole systems on one little piece of silicon. And one example of device which is using one of SOMs is this little portable medical device which is used for detection of skin cancer. So device is using Snapdragon 410, I believe, system, which probably some of you in the audience have on your mobile phones as well. So that little chip runs full Linux, and also for the UI they use Qt library. So that brings us to the Qt library itself. So Qt is one of the very popular choices for the implementation of user interfaces these days. It has some very nice features like memory consumption and CPU usage. And also it has a very rich set of various kind of graphical controls. Also it has very good tools. It's very well supported by various kind of tools, and of course it runs on different kind of operating systems which we find on the embedded devices. It is supported commercially but also through the open source. So details of the Qt library is something which is a little bit more interesting for the software developers, but for the software testers we are a little bit more interesting to see how to test applications which are developed using this Qt library on embedded devices. Squish can be used to do that, of course, but before we get into the details of Squish, let me first show you the overall architectural overview of Squish. So there are three main parts in Squish. They are Squish Runner, Squish Server and Squish Hook. In addition to that, there's Squish ID, which is an integrated development environment for development of tests, which can be used for the development of the tests. So once when you have your test script, what is happening is that Squish runner executes the test script, and then some of the commands from the test script, like mouse click or type, are sent to the Squish hook via Squish server, and then Squish hook execute those Squish specific commands. In addition to relaying the commands, Squish server can be also used to launch the AUT, so the application which you want to test, and also it can be used to inject Squish hook inside of the application which you want to test. So based on the possibility to launch external applications on the embedded devices, in general we have 3 cases when it comes to how you can organize these components for your particular test setup. So if you can run external processes on the embedded device, then the most convenient thing is to run their Squish server as well. So on the embedded device you run Squish server, your application, and the hook. And on the tester PC you run Squish runner, and then if you want you can also run Squish IDE, or maybe you can use Jenkins plugin or even run Squish runner from the command line tool. So in that case, so these 2 components are on one side and these 3 are on the other side. For the communication between devices, Squish uses TCP/IP protocol. So if you have a little bit more limited device on which you cannot run Squish server but you can still launch processes, this is what you can do. So now Squish server can run or runs on the tester PC, and on the other side on the device you use one Squish component or Squish program which is called start AUT, and then you use that start AUT program to start your application, and then start AUT will inject Squish hook into the application. This can be useful if you have some kind of kiosk-like application which starts immediately as you turn on the device. So in that case you first use start AUT, and then start AUT launches the application. And there is a third case that would be the most limited test case, and that is when you cannot run any kind of external processes on the device. So you simply cannot launch external processes. And for that case, the only thing which is then left is to make Squish hook a part of your application. So Squish hook has to be built into the application. In some cases, so it could be that we cannot provide out-of-the-box Squish packages for your embedded test system, and that's of course understandable because there are lots of possible customizations of software development kits. Qt library can be highly customized, so it's simply not possible to predict all kinds of combinations which could happen. So in some of these cases then you might have to compile Squish from sources for your embedded device. So Froglogic offers Qt Embedded SDK as an available additional commercial add-on. Building Squish from sources for your target embedded system is not that hard these days. It boils down to running of these 3 commands: configure, build, and build install. So basically you have to tell Squish configure where is your Qt which you want to use, so the Qt which is used on the embedded device. You have to specify a few additional arguments, but they are not that much important at the moment. You can see the details in the documentation, and after building then you install that into some temporary directory, and all what is needed for running on the embedded device, so that can be Squish server, start AUT, and similar programs are here in this device, in this directory, sorry. So for the third case, when you don't have any other choices than to make Squish hook or Squish built-in hook a part of your application, then this is the way how you can modify your application. So you just have to change or add these 2 lines to your application. You can of course guard this call based on some command line arguments, or you can even leave it as it is even in your final application, but just in that case you should not ship the Squish DLLs, so the things which are previously being built. If there are no Squish DLLs or additional components on the embedded device, so this call here is practically no op. That would be this part here is something which is of course happening on the on the device side and on the Squish side, or tester on the Squish ID side or the tester's computer, you have to tell Squish where is your touchable AOT. So once when you make an application attachable, and when you call this allow touching, you specify the port number on which Squish hook is listening. So obviously you have to tell Squish ID or Squish itself, which is running on the tester computer, what is the port number of your device, and also you have to specify the IP address of the device. The other option is that if you have more capabilities on the device, so if you can run Squish server on the device, so you don't have to bother yourself with putting Squish hook into the application during the compilation time. What you can do, you can also specify here where is the remote Squish server, or what is the IP address and port number of the Squish server which is running on the remote side. So don't be confused here that this port number is different than this one here. So this is the port number of the built-in hook or the application itself, which is listening for incoming Squish connection, and this port number here is the port number of the Squish server itself, which is running on the remote device. Okay, let me show you now how all of this looks in practice. For the purpose of this demo, I prepared one simple Qt application. The application will be running on this development board. The development board has 1 GB of DDR3 memory. It has one ARM Cortex CPU and one micro SD card. So the operating system and the application are stored here on the micro SD card. This is how the setup looks like. So the development board is connected to my laptop via this little mini router. On the right side of the development board we have one 10-inch display, which is of course also connected to the development board. This is how the setup looks like. So I have this on one little webcam. The development board is inside of this green enclosure, and this is the 10-inch touchscreen display. So currently the development board is running this simple Qt application, and the application is just one simulation of an electrical car. So for example, as I increase the speed of the electrical car, you can see that the power consumption goes up. So let's see now how we could test one such application with Squish. This is the Squish IDE, and I guess you're already familiar with this IDE. From Squish IDE we can connect to the application. We can just attach to the already running application, or we can just start recording immediately. So let's do that. So all actions which I'm now doing on the application inside of this little development board will be recorded. Let's say that I just increase the speed to about 40 kilometers per hour. And then I would like to verify that indeed this gauge here shows 40 kilometers per hour. To do that, I can just insert one properties verification. So same like all other properties verifications in Squish and on the desktop application, you can use Squish picker or this green pipette and pick the object in which properties you are interested in, and on the lower right side of Squish ID you will get all current properties of the picked object. So somewhere here there should be a property called value. Here it is, and it is indeed set to 40. I can save and insert this as one verification point. Also, for example, just to make things a little bit more interesting, I can also for example insert one screenshot verification point, and I can do that on, let's say, on this power meter. So again, I will pick the object which is interesting for my verification. That will be this peaker, that will be this power meter, and then I can just tell Squish to take a screenshot of that power meter. So the screenshot is successfully taken, and I can of course insert it as a verification point. And that would be more than enough for one little test suite. So let me show you now how this works on replays. So I'll just click on the play button and Squish will now execute the test on the device. Let me show you now, for example, what would happen if we didn't scroll to 40, but let's say to 60. And let's say that we also expect that the value of the first gauge is 60, but let's intentionally leave the screenshot of the second gauge or power meter to wrong value so that you can see how a failure looks like. So let's replay this. So as you can see, the first comparison passed because we got indeed 60 kilometers here per hour, or maybe let me show you that. So yes, it is indeed that first gauge is at 60 kilometers per hour, but the second gauge is not at the position we expected. And you can even see the differences here. So what was wrong? So as you can see here, so expected value was somewhere around 15 kilowatts, but it is more than 20. So this is how failure of one screenshot verification looks like. So okay, that would be all for this demo. Let me talk now about some common problems and challenges which you might have. One of the first things is the communication with the device. The communication in Squish is based on TCP/IP protocol, and that means that both the device which you want to test and the tester's PC have to be in the same network. The network can be wired wireless, or you can even use LAN over USB if you have such possibilities. So like with any network, you might have problems with firewalls, so you have to check is there anything what is blocking the communication. And in the case if you are running Squish server on the embedded device, you want to check the file called Squish server RC in the etc folder, and inside of that file, there is one setting which tells Squish from which hosts the connections can be accepted. So we don't want that anyone in the network can connect to the remote device, so you have to specify there who can connect to the remote Squish server. That is, of course, because of the security reasons. The other thing which is quite common is the control of the external hardware or the environment of the embedded device which you want to test. Quite often some additional hardware like instruments or some tools which you find around embedded devices have some additional Python libraries which you can use, of course, in Squish in your test scripts in order to set up the environment before the test or during the tests. Also, sometimes that environment around the embedded device, or sometimes even on the embedded device itself, there are some additional programs which can be also automated by using Squish. So you automate another second application with Squish, and in that second application you can set some parameters of your device, maybe trigger some actions or whatever that second application can do for you. So you automate that application from Squish, and then in your test scripts you have capability to control the environment in which your main application or your main tests are being executed. Also, another option to interact with the environment around embedded devices, FMI test, FMI interface support. So that's something that is introduced in Squish relatively recently, and you can check that in the Squish documentation a bit more about that. If there is no way that you can control the environment of your embedded device, for example, if it's some kind of microwave or oven, and somewhere inside of your test scripts you have to close the door of that microwave before you continue with the tests, you can use Test Interaction API, in which you will just pop up one dialog in your tests in which you will just say like, please close the door now, and then when human being close the door and presses the OK button, then you continue with the tests. So that won't be the fully automated tests, but it's still way better than doing everything manually. Then the next thing would be soft and hard keys. So quite often people ask, like, what is the key code for some of the hard or harder buttons, or what are all these soft keys and soft keyboards. So that is mainly the same like what you have in Squish when you are using external keyboard. It's just that key events are coming from the virtual keyboard. So from the application's point of view, there's not that much difference. Regarding the physical buttons, they are usually mapped to some functional buttons like F3, F5, F10. And you can see that easily if you just start simple recording on your application, which is running of course on the embedded devices, and then you press those physical or virtual buttons and then see what gets recorded. Then recently we saw that quite some customers have problems with actually access so people cannot access the embedded devices. So for example, it could be that tester and his PC is in one building and the actual device is another building, or it could be that the device doesn't have display yet, simply that's the part of the development process. So what we developed in Squish 7 is the remote control feature. So that's feature which works similar to VNC or some remote control programs. So let's get back to the camera and let me show you that again. So what you can do, so from Squish you can attach, so previously we just did some simple recording, but now we can just attach to already running application. And once the connection is established, we can just use these remote goggles or remote control button, and inside of that remote control you will see the window. Let me just zoom this a little bit, which corresponds to the state of the real application. So for example, you will see now if I move this slider here, then you also see that in the remote view application changes its appearance. Things also works other way around. So if I just move this scroller a little bit on the left side, you will see that in the real application the scroller is also moved on the left side. One more thing which is also happens in this situation when you have to use built-in hooks, so the application runs in very limited environment. Quite often you want to start execution of your tests from a very well defined state so that you know where you are. But if you cannot restart the application, then you have to find some way to bring your application into very well defined state so that each new test starts from the same point. It wouldn't make sense if one test then can change the state of the application and that affects some other tests. That can be of course done through a little bit of scripting. So before you execute your tests, you have to see where is your application and to bring it into some new very well defined state. It could be also that there could be some hidden features in the application UI which you can use to, for example, restart the device itself, and then once the device is back, then you can use, you know that your application is in its initial state. For such things, you can also use your own hardware. You can develop some additional hardware for that, but you can also use something what is called on-premise device farms. So one of our partnering companies, Timesys, developed this set of devices which helps you with some common tasks like turning on and off power of your device, turning on and off Ethernet access, turning on and off USB ports. You can even have, as you can see here, you can even have here one virtual micro SD card, so that from your test scripts you can change the SD card or the operating system image and the application on your device before you turn it on, and in that way you can support multiple scenarios. And that will be all for this talk. If you have some questions, feel free to send them to me. My email address is slobodan@froglogic.com, and thank you very much for your attention. Goodbye.